Right, number 221 from Advanced Higher Maths camp. First order differential equation where the variables are separable. This one representing actually the rate of progress of a chemical reaction whereby two separate compounds combine to form a third compound X. And so obviously the rate at which the reaction proceeds depends on how much is left of each of the compounds and their ability to find each other, meaning also that X is going to be less than A and B. Well, starting off to begin with. Well, dx by dt is k times A minus X, A minus Right, number 221 from Advanced Higher Maths camp. This time a first order differential equation where the variables are separable. This one actually represents the rate of progress of a chemical reaction whereby two compounds react to produce a third one X, and the rate of production of X depends on how much is left of these two different amounts A and B. So X is necessarily less than A and B. Well, first of all, dx by dt is k times A minus X, B minus X. So first step, separate them. So I've got dx over A minus X, B minus X will equal k dt. And you can integrate both sides. And then the first thing that becomes obvious is the technique required to integrate this is going to involve partial fractions. So hopefully I've got room at the side here. So we'll have to let that equal, or maybe I'll just do it underneath and then we're going to about afterwards. So let 1 over A minus X, B minus X equal A over A minus X plus B over B minus X. Which means that, multiplying throughout, A times B minus X plus B times A minus X will equal 1. And then either by equating the coefficients or just using some knockout values here. So if we put in X equals A, that means I'll be left with A times B minus A, and that'll just be 0, will equal 1, which means that A equals 1 over B minus A. Then letting X equals B. That means that goes, and I'm left with B times A minus B equals 1. So that means B equals 1 over A minus B. Now I'd rather have had the same fraction, but I do, because that's just the reverse of that. So I'll rewrite that one as negative 1 over B minus A. Now I can go back and inform the original parts. I'll put them down here. So that means the original part would be, then I'll clear the board, would be A over that. So that's actually 1 over B minus A times the A minus X minus, same multiple, B minus A times B minus X. Well, pause to rub that. Right, cleared the space there, so I can replace that with what I had before, which was 1 over B minus A, because that was a common factor, times the integral of 1 over A minus X minus 1 over B minus X dx equals integral of k dt. Right, let's just back again. So for this, what have we got? We've got 1 over B minus A times, now for this part, that's just a logarithm, so that'll be ln of A minus X, and that's definitely positive, but divided by the derivative of this, so it's divided by negative 1, so it'll be minus ln of B minus X divided by the derivative of that, which is negative 1, so I'll turn that into a plus. And that will equal kt plus c. Now I could bring that across, but I'll leave that where it is just now because I'd rather work out c as soon as possible rather than having gone through several levels of algebraic jiggery-pokery. So I'll leave that as 1 over b minus a times, and this can be tidied into a single logarithm. That's been subtracted, so that'll be underneath, of b minus x over a minus x, and that will equal kt plus c. And I can call this in. When t is 0, x is 0. So I've got 1 over b minus a times ln b over a equals c. So c equals that. So I could put that lot in. I'll have 1 over b minus a ln b minus x over a minus x equals kt plus, and c is equal to this, 1 over b minus a ln b over a. Get rid of this bit here. And now I can knock out all of those, multiply them by b minus a. So I've got ln b minus x over a minus x equals, and it'll have to be b minus a kt plus ln b over a. Now I'm not going to try and change that b minus a into some constant c. I've already dealt with the constant. That's not just some arbitrary constant, those were the initial values. So I've got log minus log. I've got ln b minus x over a minus x minus ln b over a equals b minus a kt. Subtracting the logs, so I'll produce dividing by this as a fraction divided by a fraction, so make it the fraction times the reciprocal. So it will be a times b minus x over b times a minus x equals b minus a kt. And obviously get rid of that log then, which means I would have a over b times b minus x over a minus x is e to the power b minus a kt. Now it's going to look like that last question. So the next part would be get rid of this fraction here. So I've got a times b minus x equals b times a minus x, taking that across and multiplying, e to the same thing. Now I want to get the x's together to get the answer. So I'll need to multiply this lot out. I've got ab minus ax equals, just put that around, abe to the b minus a kt minus bxe to the b minus a kt. Bring the x's together, bringing this over to this side. I've got this, I've got bxe to the b minus a kt minus the ax equals abe to the b minus a kt, bringing that part over, minus ab. Now factorising the two parts, well, taking the x out of this, I'll take it out behind here. I've got be to the b minus a kt minus a, lots of x, ab's can come out of this, equals ab times e to the b minus a kt minus 1. Then I'm not sure if we've got room down at the bottom, but to finish it all off, finally I've got x equals ab e to the b minus a kt minus 1 all over be to the b minus a kt minus a. Done.